So we'll get to that in a second. This is a cute video. So again, we're going to be talking about OpenCV today. And again, with a lot of these things, one of the big problems is like these are all technologies in order to solve problems. There's Jock. It's in order to solve problems. And so one of the big issues you have, especially in the modern world, is people aren't taught to solve problems anymore. And again, I'm not being snarky on the other people. It's just true. It's just a fact. All right. When I was growing up, you're expected to deal with crap. Just do it. Again, I knew how to fix everything in my car. I literally changed the oil in my car for like the first 20 years until I got to the point where I got tired of dealing with used oil and had somebody else do it. But anyways, that's one of the big problems nowadays. Is everybody like wants to learn technology? Like, I want to know AI, which is fine, good, whatever. But the issue is the fundamental. They don't know what the fuck they're gonna do with AI. I want to make $1 billion with AI. I'm gonna create an AI business. And you're like, okay, cool, whatever. What problem are you gonna solve with AI? That's worth $1 billion. And they're like, And that's where everything goes to hell. That's where everything goes to hell. So anyways, this is one of the projects I did. If you've been following me, for a length of time, you may remember this project. It's my little robot. It's actually sitting over there in a corner. It's going to come back. It is my anti-Lewis Rossman robot. See, that's how I'm going to make my $1 billion. I am not going to make $1 billion selling a robot. I am not going to make $1 billion with an AI-powered robot. I am going to make $1 billion by selling Apple the solution to Lewis Rossman. Anyways, that sounds creepy. Anyways, this is a weird ass robot. Basically, it's got a camera at the top. It's got a screen here so you can see what the hell it's seeing. And it's got a full, I think it's an A6. It's an A6 computer on there. 4 gigahertz processor, 32 gigs of RAM, 1 terabyte solid state storage, graphics card, the whole 9 yards. And so anyways, basically what this does is it follows the face. And so as a hash, I was playing with this at hash, and this girl came up, and she stole my robot. And so to kind of give you an idea, and like in the physical world what these things can do, this is kind of what you're looking at. All right? So basically it sees her face, and it also, based off of the size of her face, it uses that as correlation for distance. And so basically what it's doing is it's following her and moving and going forward or going back, basically entirely off of OpenCV. So OpenCV can give you the x coordinate of an object, the y coordinate of the object, the height of the object, and the width of the object. And so with that, once you have that kind of information, you can use it to create projects like that. So that is kind of an example of what you can do with OpenCV. And I don't even know how to use QuickTime. Anyways, no, go away. Let's see here. Class intro. So if you're new to class, motion, where are you just here? Anyways, you're new to class. Silicon Dojo, authoritative, gatekeeperless, free to use your hands-on technology education that empowers you to do whatever the hell it is that you want to do. Again, I'm a Buddhist. I'm a bad Buddhist. Don't worry, I'm not going to proselytize. I'm not particularly good at it. But anyways, one of the things I always think about is when I was younger, right, I would read the sutras for Buddhism. And one of the things that always hit me was, right, in order to teach Buddhism, right, back in the day, basically you needed the master, you needed the student, and you needed a tree, right? And the only reason you needed a tree was basically to keep the sun off, because it's India. And India's fucking hot. Been there before. Ooh, right? But that's the thing, right? Imagine if you're teaching enlightenment, right? The very concept of why we exist, not just why we exist, but how to interact with the world within that existence. Think about how valuable that is. And basically all you needed as a resource was a tree. Was a tree. And now you look at the modern world, and people are going $100,000 or more into debt for gender studies degrees. I think there's a bit of an issue there. So anyways, that's kind of what we're doing with Silicon Dojo, and my thought process is what if we can get back to education where the resource is a tree. Again, Buddhism is about the middle way. We are in the modern world. You need more than just a tree. But again, Zoom, a crappy computer, some other stuff. We can probably do education for a good bit less than what we're charging in the United States. And so that's kind of the idea with Silicon Dojo. Again, donor box, it's not actually free. This 100 square feet of studio space cost me some money. Yeah. Anyways, so if you want to throw some money, we have a donor box link. I'm going to advertise it more. I just don't get around to it. donorbox.org/ETCG. If you'd like to throw in $1 or $5 or $100, do have one of those per month, or one time to help support this, that would be ever so lovely. If you have a question at any time, you can ask a question in Zoom, by raising your hand, wherever the hell that thing is. I can't see it because I got too much crap on the screen. Again, you do that, and when looks like you're done talking, so we'll lower your hand. Anyways, I don't know what Zoom is doing. So anyways, raise your hand. I will get to you just as soon as I have a break in the class. Makes life easier. Copyright, basically, again, this is kind of the Buddhist principle. Take it. Take it. Have fun with it. If you can make money off of it, great. If you take everything that I'm teaching you and you go to Mogadishu and you create a for-profit academy in Mogadishu, God bless you. Just don't take my... my little logo, my little smiley face, that actually is copyrighted. All the other information is up to you. Tippy tap or die. Again, if you want to be a technology professional, it is not simply about you listening. It's about you actually doing the work. Today, we're not actually going to have labs just because everything is actually code that you can go around and you can play with on your own. Normally, we do have labs. Again, do those labs. If you want to be a technology professional, do the damn labs. You can't fail. You can't fail. But anyways, extra help. If you need extra help, W3 Schools is fabulous. Not very useful for today's class. Or ChatGPT, which is actually great for today's class. Again, ChatGPT is not artificial intelligence. It simply is not. That's branding. It's crap. It's for investors and stupid normies. But it is still incredibly useful. So ChatGPT, especially for configurations like things today, it is actually really good for explaining like little nuances in the code. Standardization, we use VS Code with default settings. Basically, normally when we do the classes, it allows me to help you folks out. If everybody's using the same environment, it makes life easier. Again, that's why you shouldn't use Windows. That's your business. Extra material if you want it. Again, all the material here is on GitHub. So for any of these classes, if you go and you take a look, you can go to GitHub/SiliconDojo/online classes. All of the classes we've done so far are here, and then there's a material. I don't know what the hell are we doing. OpenCV for computer vision. So if you open this, you'll see there's a thing for code examples for today, and there's slides, and there's a workbook. I would always recommend that you download and print the workbook, just so you can follow along and you can write notes. Everybody thinks that they do not need to write notes, and everybody is, say it with me, wrong. Write notes. Anyways, there's also... the classes will be on YouTube, so the TCP/IP for programmers, other stuff has been up there. We're now recording this 4K over on a second camera, so we'll have some decent quality there. Let's see here, and if you're interested, I got booted, I guess. I do have my LinkedIn account. I do put some stuff up there that might be different than stuff I put other places. So that exists. Let's see here. Beyond that, trolls, not to worry about. And imposter syndrome. Again, I just sometimes talk about a little philosophical stuff before you get into the class. I think this was an interesting thing, again, talking with you guys about Buddhism and all that. And this whole idea of imposter syndrome comes up a lot. Anyways, I think this is an interesting thing to think about, again, especially from the Buddhist perspective. Because a lot of people are like, Eli, how do you deal with imposter syndrome? Put a little girl down. And basically, right, so Buddha Siddhartha, years ago, he's sitting under a tree with students, and he's talking about the different levels of enlightenment, right? Your way to nirvana or whatever. And anyways, right, so the first level is no enlightenment, second level, some enlightenment, all that kind of stuff, right? So the first level, you're kind of pissed off, you hate everybody. Second level, you're kind of pissed off, maybe you don't hate everybody. Third level, anyways, basically going up to define enlightenment, nirvana, all that horse crap. But anyway, so as you're going up, right, there's changes. There's changes in how your brain works as you go through the different levels of enlightenment. As always, I forget which level it is. It's like 6th level or 7th level. They're like, oh, Buddha, How do I know when I go from level 1 to level 2? And he sits there and explains. How do I know when I go from level 2 to level 3? And he sits there and explains. 4, 5. I don't know, somewhere at 6 or 7. I think it's like 7 to 8. Anyways, well, how do I know when I go from level 7 to level 8? And Buddha, under a tree, looks at the student and says, you will never know. The student's like, what? What do you mean I'll never know? It's like, you will never know when you go from level 6 to 7 or 7 to 8 or whatever. And the student's like, I don't understand. And because the Buddha sits there, and again, remember in Buddhism, it's about desire equals pain, right? Your need to grasp and to try to control existence basically is what creates your pain. You don't go to heaven. You don't go to hell. It's where you are. Anyways, and so basically, Buddha looks at him and says, by the time you're going from level 6 to level 7 or 7 to 8 or whatever it is, you will no longer care, right? Because it's desire. I want to get to level 4. I want to get to level 5. I want to get to level 6. Somewhere between these levels, 6 to 7, 7 to 8, whatever the hell it is. You will lose that desire to want to get to the next level. Ergo, by the time you get to the next level, you won't give a crap. You will not think to ask the question at that point, what level you're at. And if you don't ask the question, then you'll never know the answer. And I think that's an interesting thing to think about, like imposter syndrome in the tech world, right? Because again, all these 18-year-olds, oh, I'm an imposter. I don't know. Just realize as you keep trucking along, as you keep moving forward in the technology world, at a certain point, you're just not going to care anymore. You're going to be like, look, I got hired to do a job. I was given a certain amount of resources. I did my best. Anyways, that just came up. Recently, so thought I'd talk about that a little bit. Anyways, so let's get to Python. OpenCV for computer vision, because OpenCV is really cool. So basically OpenCV is computer vision, and basically what it does is it allows your computer to look through the webcam or whatever the hell else you have connected to it, and it allows it to see the world, which is a lie, actually. It doesn't see the world. It allows it to input images and calculate the positions of pixels vis-a-vis other pixels, and based off of statistic analysis, correlate that to a name that you put into the system. That's actually what it is. I know I sound pedantic when I keep saying it's not AI. I get it. I'm not a cool kid. I'm not an alpha male. And so I come here and I say it's not AI, it's not computer vision, it's not that. The important thing I want you to be thinking about is when you put names on things, you dump so much visceral baggage onto that thing you're giving a name. And the problem is, it really screws up how you use a thing, right? If you have a system that does natural language processing, is it even going to come to your mind that it's racist, sexist, or whatever else? Well, that's stupid. Eli, it's a natural language processing system. Obviously, it's not racist or sexist or whatever else. It's like, okay, but then why are you complaining that the LLM is racist and sexist? Because basically, it's just a natural language processing system. Right? If you think about a system, it's just simply doing a statistical analysis based off of data points. Right? Are you going to think about that the same way as you think about quote-unquote artificial intelligence? No, right? That would be stupid. And again, so that's one of the reasons why I keep hammering home this whole idea that this AI garbage really is not AI garbage, is because people are trying to put too much onto it. And then their expectations are just insane. They're just insane. Again, if you look at the modern world, the expectations for AI is just ridiculous. So one of the things I want to talk about first here is that monkeys are not real. In my world, in the world of Eli the computer guy, monkeys don't exist. You might be sitting there like, what the hell does that have to do with the damn thing? A lot. And that's a lot, right? Because one of the big things you may have seen a couple of years ago, Microsoft comes out with their AI computer vision horse crap. And the black people are like, oh, this is cool. And they take pictures of themselves. And then Microsoft calls them monkeys. Well, one of the things I want you to think about is, again, computers do not see. Computers do not think. Computers do not have lived experiences because the damn things don't live. What is a computer doing? Right? It's taking an image. It's taking an image. It's trying to find things that it thinks are significant on that image, and then it's trying to correlate, vectors or whatever based off of those things to determine what it is, right? You hold this up, it does a whole bunch of vectors, and then it takes those vectors, those numbers, it goes off to its version of a database or data store and says, what does this vector match? And it comes back with dry erase marker. I show it this, vectors go off, comes back, dry erase eraser. That's what's happening. So one of the things to be thinking about, again, when you start using computer vision systems, is if you have something that has two eyeballs that look forward, that has a nose that's basically here, that has a mouth that's basically here, and has ears basically here, all it's doing is vectors based off of that, sending that off to a data store and saying, hey, what do these vectors match? And if it comes back monkey, it will state monkey. The AI, the system, is not being racist. You just gave the system a very dumb option to respond with. And so one of the things to be thinking about when you design these systems is, again, to be thinking about how people are going to be interacting with these systems and simply rip out any response that might be bad for your company, right? Again, does your company have any business with monkeys? If it doesn't, there's no reason for your system to ever respond with monkeys. And I know I talk about this with a lot of folks that look like me. And they're like, oh, Eli, these people, these woke people. But the funny thing is, that it's not just the woke people. I had this with, so I used to do the in-person classes. So the Silicon Dojo, the original part of Silicon Dojo was supposed to be a physical in-person class. And, I'm talking about this, basically doing the same rigmarole, only with people in front of me. And, Jesus, this guy could not be more stereotypical. Anyways, there's a very stereotypical guy sitting right in front. Middle-aged, overweight, all these woke people. Anyway, so he's going on about this crap. The funny part was, two people down from him, there's like, I don't know, whatever it was 10 people per row, 2 rows. Anyways, 2 people. There's this woman that was 2 down, and the OpenCV system just fucking refused to detect her. I still don't understand what the hell was going on. It was bizarre. Like OpenCV was like, no, I will not see you. Literally, there's a woman behind this woman, and her script would trigger based off of that woman, but would not see her. All right? And again, this guy is sitting there like, oh, this woke garbage. At the exact same time, I'm trying to figure out why the hell this system doesn't work for this woman. It works for everybody else in class. OpenCV just doesn't like this girl for some reason. I don't fucking know, right? But anyways, that's the kind of thing to be thinking about with these systems. And again, especially as you start automating systems. Again, one of the things that we're going to be doing today is we're going to do like auto tagging. So basically you look for what's called a filter, a cascade filter. But basically you look for specific things. So let's say people's faces. So let's say you have a company. That company has 100,000 pictures. That would suck to go through, and it would be very expensive, possibly to put through OpenCV. So what if you simply want to use, or put through OpenAI? So what if you want to use OpenCV to simply go through, scan for faces, and then basically tag every image that has a face in it, and then you could use that for HR purposes or whatever going off in the future. Again, what if it doesn't trigger off of certain faces? And then all of a sudden, you have a chunk your employee base that simply is not represented in any damn image that's used publicly. Right, and that's the kind of thing to be thinking about with these kinds of systems. And as we automate these systems with quote unquote AI, which is not AI, it's just simply statistical analysis, and verifying that one, it does what the hell it's supposed to do, and then two, making sure it doesn't return very, very stupid results. Because, yeah. Anyways, let's see here. So why OpenCV? So again, we have OpenAI right now. OpenAI has vision services. Azure Cognitive Services has vision services. There are a lot of different things out there that have vision services. So the question is why even bother with OpenCV? The big thing is that this OpenCV actually runs locally. So there is no API call here. So basically, once you set this thing up, once you train it, all that kind of thing, it doesn't need a Wi-Fi connection. It doesn't need a TCP/IP connection. You can just set it up and it does whatever the hell it is that you want to do. So again, let's say you wanted to take pictures of, I don't know, security, like an off-grid security system where you just wanted to take a picture every time it sees a person. And then it has an SD card. You can pop out the SD card and plug another one in, and it just copies the SD card. You don't need a network infrastructure, right? That's the kind of thing that you can do with OpenCV. Also, since it's local, again, the more resources you have, the better. Just because it can run on a Raspberry Pi doesn't necessarily mean you want it to run on a Raspberry Pi. But the more resources you give it, it can actually perform very, 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 very quickly. So that's one of the things to be thinking about. One of the big things to consider is going to be camera resolution. So when you start running these things, again, especially with whatever computer you're using, let's be honest, if you're using a Mac, Macs don't have the best webcams in the world. Basically, it can only do that statistical analysis based off of pixels, based off of the amount of pixels that it has, right? So if you have a 4K camera and your computer is actually able to process the 4K camera, you're going to get much better results than, again, the camera off of a MacBook Pro from 2012. I think it has like a 480p camera. So again, that's one of those things to consider. And again, when we talk about the stack, right? Whenever we're developing solutions, we talk about the stack. The stack is OpenCV with the operating system running under it, with the hardware running under it, the whole 9 yards. That whole stack comes together to actually give you your solution. In order to set this up today, basically all you need to do from your computer, if you want to, Python 3 space -m pip install OpenCV -python. I don't know why you gotta do that, but you gotta do that. That is the command, and then it will download and it will install onto your system. For the other projects that we're gonna be doing today, we're gonna do some bounding box projects. You also need Pillow. Pillow allows you to interact with images on your operating system. So again, basically you can install Pillow too. You don't need Pillow for the videos and for a lot of things. You don't need Pillow, but that would be useful. Then you also need to download what's called the data folder. So what we're going to be doing today is we're going to be using one of these Haar cascade filters. Basically, you have to download it from somewhere. You download it from OpenCV. Basically, you go to sources, you download the data folder, you put it into your root directory. So again, for most of you, unless you know how to do it differently, put it into your user's root directory, and then you'll be able to access it. So filters. Basically, all filters are numbers. You want to see what a filter is? You want to see what powers AI? Oh, you're going to be so passionate about it. You're going to be like, oh my God, I'm so passionate about that, Eli. Oops. Never mind. Hold on one second. I got to go back. Let me show you what is going to power what we're dealing with today. I think we're doing an alt face, cat face. There we go. I think it's frontal face. So that's the XML file. And so basically the XML file that you're going to get, and this is what powers everything. Basically looks like this. Yep. Very exciting and very interesting But this is the math that powers basically OpenAI. So essentially what you do in order to get a filter, we're not going to do it today because it gets a bit complicated to do, but you can manually train these filters. So basically what you do is you get a bunch of pictures that have whatever object it is that you want to be able to detect. You also get negative images, so images that do not have that object at all. And basically what you do is you run a series of scripts. The first one goes through and basically it opens each one of these images. You basically draw a square around the object that you care about, and you do that 200 or 2,000 times. Then you run it through this script, basically, that does the training. You see it as it trains and tries to figure stuff out. And then basically the output is going to be this XML file right here. And so again, I don't know where intelligence starts, but I don't think this is where it starts. One of the big things to be thinking about with these filters, so again, these are basically just text files. Text files you can copy, you can paste them, whatever else. But there is licensing. So with the ones that we're dealing with today, Intel license agreement for open source computer vision library, copyright 2000, and it explains stuff to you. Again, that's one of the things to be thinking about as a technology professional, right? As a decision maker in the technology world, it's not simply that you understand the configurations and all that kind of stuff. You need to understand the licensing too. And so if you're going to be deploying this particular solution, not only do you need to understand the licensing for OpenCV, which is open source and all that, but for any of these filters that you're going to be using, you also do have to verify the license for them. It may be worth it for you to simply do your own training for a model so that you don't have to mess with this crap going forward. Let's see here. So the webcam video. So I'll just get into this. We'll see how well this works. It is funny when I do so many of these classes because I have my, what do they call it? My daily driver. I have my daily driver computer here. That's an M2 Max. It works so well. It works so well. I don't care what you say. I love my M2 Max. Anyways, this thing works really well. This is a 2019 Intel, what we use here, 2019 Intel MacBook Pro, and doesn't necessarily work as good. But let's go over and take a look at this particular example. So the first thing that we're going to be doing is the webcam script. Let's do the settings here. Let me change the font size for some reason. Let's take it down to 24. Okay, that's going to be a little easier to see. So there's a lot of stuff in here. If you go to the GitHub account and you download it, most of this is copy and paste. Again, with a lot of stuff in technology, there's a stuff that you need to be smart about, and a lot of stuff you need to copy and paste. Much of this is just simply copy and paste. Why do you do this? Because they tell you to. Really, that's about the answer. So basically what's going to happen is when we run this, let me just run this so you get the example, we're going to see a video image come up, and then we're going to see it track my face and track my eyeballs. So run that. There we go. So this is weird. I got so many cameras going on. Okay, so I'll look at this, and then you look at that. Anyways, all right, so as you can see here, this is so weird. Too many cameras. Too many cameras. Anyways, so you can see my face here. When I look straight at it, basically you see there's a circle around my face. And then you can also see that there's eyeballs within my face. So basically this can see that there is a face here, and there are eyeballs in it. Let me see here. Come here, girl. Come here. Yellow chihuahua. Nobody ever gets insulted by a chihuahua. We'll trigger off a chihuahua face. Oh, no? I'm actually surprised there. Sometimes it triggers off the chihuahua faces. Anyways, so there you go. So you have a human face and a chihuahua face, and it only detects the human face. With this, if there's more people in the background, pictures of anybody, but there are more people in the background, it would detect everybody, and it would, everything would be circled. Okay. Let's go and take a look at the code. So if you're running this, so this is running, right? You do need to make sure you stop it here. So make sure to stop it within the Python script itself. And we can take a look at this code now. And again, a lot of this is just pretty copy and paste. So we'll go through, yep. Okay. So if you look up here, I just left this in here because it's there for some reason. So again, there used to be something called Python 2. Don't use it. Do not use it. For some reason, they just left this in here. This is basically for code, for Python 2 code to be able to work in Python 3 world. It does something with quotation marks, whatever, for print commands. This can actually be deleted. I only left it there just because, you know, whatever. Import CV2 as CV. So it's called an alias. So basically we're importing the CV2 module, and then we're going to be calling it CV from this point forward. And then we're also importing a module called argparse. And basically this is so that we can add arguments to our script for additional information. Again, arguments is not rar, arguments is paths and that kind of thing. We have our main function here. We're going to have the detect and display. We'll get into that in a second. And so that's the main function that's going to be running. And that's what's going to display the faces and the eyeballs and such. From there, we're going to come down here. We're going to use that argparse module. And we're going to add arguments, right? So we're going to add a description argument. We're going to add a face cascade. And that default is going to go to data. Haar cascades, Haar cascade, frontal face alt XML. So this is an important thing. So this location, right? So I talked about that data file before. And so you're going to go to OpenCV. You're going to download the source file from that. And in there is going to be a folder called data. You need to put that data folder into your root directory. And when you go here, I don't know if you can see it, but there's something called Haar cascades. And from there, these are also the different cascade filters that you can pick from. So basically, for the face cascade, you just need to put in the cascade filter, the location of the cascade filter that you're going to use. We're also going to create an argument for eyes, so we can try to determine what an eye is. And again, data Haar cascades. It's going to go to Haar cascade eye tree, I guess, with eyeglasses. Down here is going to be an important one, depending on what computer that you're using. So whenever you're interacting with the hardware in your computer, it has an address. Generally, your microphone has an address, your webcam has an address. Generally, it's going to be 0. Generally, it's going to be 0. So add argument camera, whatever, and basically default equals 0, should be at index 0. The one thing that I will say, so Intel MacBook Pro from 2019 wants this to be index 0. 2023, right, MacBook Pro wants it to be index 1. For some reason, with a continuity webcam, so where you can use your phone as a camera with these new ARM-based ones, they want it to be index 1. So anyways, when I'm running on here, I do default equals 0. When I'm running on here, I do default equals 1. That will probably be one of the big things that will screw you up. Let's see here. Just go through, again, a lot of copy and paste. Face cascade name equals args, face cascade, args, eye cascade. Some things with classifiers here. Let's see here. If not, face cascade load. So basically, if for some reason it can't find the face cascade, it's going to print out an error. If it can't find the eye cascade, it's going to print out an error. And then camera device equals args.camera. So basically, it's going to go to those arguments for the camera and use those. If there's a problem, it'll fail out. Capture equals CV, video capture of the camera device. If there's a problem, if you can't open, error opening video capture, and then exits. So while true, basically it's going to start reading. And we're going to come down here to the detect and display, and we're going to send frame. So frame equals what we're capturing. So basically we're capturing the video comes in, it's being read. Then we're going to send that frame to the detect and display function. And then we get up here. Again, almost all of that is going to be copy and paste, unless you need to tweak some things. The first thing that we're going to do is, again, we're going to bring that frame in, and then we're going to turn it to grayscale. And again, this is one of those issues that you get into with the whole wokeness or social justice or whatever with things like computers. take a look at a whole bunch of different pictures of people's faces, turn them to grayscale. So again, it's not even triggering off of colors, right? Again, colors is pretty like, oh, okay, those are colors or whatever. But if you turn it to grayscale, what are the points that it's going to be able to trigger off of? So basically, you're gonna turn it to grayscale, and you're gonna try to equalize it. As far as I understand, this is actually done by default. Like theoretically, as I grasp it, you could leave that code out. But they have it there, so we're not going to screw with it. Then we come down here, and then basically we're going to create a list for faces. And basically where all these faces are located. So the faces are objects. So whatever object it is that you're doing, you would create a list for that object, face cascade that we put in down there, detect, multi-scale, basically what's coming in, and that gray image that's come in, and then for X coordinate, Y coordinate, width, and height in faces. So we have a list of all the objects that were detected, and then we have a tuple. And so what it is with a tuple, again, with data sets in Python, tuples can't be sorted. Again, that's one of the things, like when you deal with Python, they have different types of data sets. They have lists, they have dictionaries, they have tuples, they have sets, they have a whole bunch of different things. And it's like, why do you have all these? And one of the reasons is because you don't want to sort this. You don't want to alphabetically sort your width and height and X and Y, because then it turns to garbage. So anyways, this is considered a tuple. Center is going to equal X plus width divided by 2. Y is going to equal height, or Y plus height divided by 2. So the weird part about it, like when it detects a face, it's going to look weird on screen. But anyways, the point that it's going to give you is like here. So it detects the face here, but the point that it's going to give you is because basically it's giving you the point of kind of like the corner where the image starts, and then you have a height, and then you have a width. So basically, in order to get the center, right, width is this. So we need to divide width by half, and then X is here. So half of width is here, plus the X value is here, that gets me here, right? Y, so we already have a value for Y coming down. We take the value for height, we divide that by 2, and that gets us here. So again, that's one of the weird things. And again, why? I don't know. It's how they do it. So again, that's figuring out the X, Y coordinate can be a little bit weird. Then we're going to create a frame. So within OpenCV, they allow you to draw on the screen. I'm going to show you more about this. You can do squares, you can do ellipses. This is ellipse, basically a circle. And so what we're going to say is for the frame equals CV, so computer vision, create an ellipse, frame, center. And so the center, then it'll be width divided by 2. So basically this is going to be radius for the ellipsis. So basically width, but it's radius. Right? Diameter is the full, radius is half. So radius for width is going to be half, radius for height is going to be half. That's basically going to give you a circle. This is some stuff for how you can pivot it. This is the color right here, BRG, I think is the color scheme. So this is what gets you that color I was showing you. And then here, that 4 is the border, or the border size. Right? And again, this is a perfect thing to drop into OpenCV and say WTF, right? But anyways, that's basically how you're able to do the circle. Once you do it, you don't mess with it too much. Let's see here. Then we're going to be detecting eyes here. What's the face? ROI. Okay. So basically here, we're going to be taking that face that we got, and basically for each one of these faces, we're going to see where the eyes are. So that's going to be one of the issues you get to deal with OpenCV, is like, what is an eye? Statistically speaking. What is a smile? Statistically speaking. So if you have a computer, and it's just trying to detect the eyeballs in this image, you're going to get a lot of eyeballs. You're going to get a lot of eyeballs. Right? Because how many things statistically match an eyeball? So basically what this process is here, is what it says is we're not going to look at the entire screen. We're not going to look at the entire screen. There's not going to be an eyeball on the whiteboard. There's not going to be an eyeball randomly here. an eyeball should be within a face. And again, this is the other thing you need to be thinking about, is thinking through this process. So basically here is where we find a face, and then here is where, if we found a face, then we look for an eyeball within the face. Again, we come down here for these eyeballs, X2, Y2, W2, H2 for the eyes. They find the center of the eyes. They do some other stuff here, basically to create a circle. And so that's going to give you a nice little circle around those eyes. And again, basically all of this is essentially copy and paste. Then you have the CV, .image show. This is important. This is what actually displays. Gives us that little video display, and basically it's then going to display the frame, and this will be the title at the top. So if you run this thing, that is where, again, this is weird, so I don't know if you can see this, so face, set title up at the top. It's not really working. Anyways, so capture face detection, then we have my face, and then we have my eyeballs within the face, and that's basically what we're looking at for the simple code. Again, that can just copy and paste. All you have to do is mess with the default number for the video camera, and it should work. Is there any questions on that? All right. Then we're going to go to the XY. Let's see here. We'll do XY. So basically, you're able to put on the display itself, you're able to put the shapes. You're also able to put text onto the image itself, right? So basically, we did the ellipse. That's how you do the ellipse. There's a circle. Again, OpenAI is great for explaining that kind of thing. Then we can also put text. So on the frame, you can put words on the frame. You basically give it the XY coordinates. You can give it the font. You can give it the text size. You give it the color, and then you get the font thickness. And that's basically allows you to actually put things directly on the video feed itself. Why this is important is we'll have a more advanced OpenCV class sometime in the future. But what you can do is you can actually stream from OpenCV. So basically, OpenCV can bring in a video feed from something. Basically, you can overlay things onto that video feed, and then from there stream out that new video feed off to wherever it is that you want to go, YouTube or whatever else. So basically, you can overlay this stuff, and it becomes kind of interesting. So the next thing is showing off with the webcam, basically the XY coordinates. Again, one of the big things to be thinking about in the technology world is once you can turn something into numbers, then you can start doing interesting things with it, right? Because again, that's the whole thing. Like computer vision, computer voice, or computer hearing, artificial intelligence, that stuff is hard. That is really, really hard. Basically, taking ASCII text and then triggering events off of ASCII text, that's dirt simple. And so if we can take things like XY coordinates, height, width coordinates, we have that, then we can start doing some interesting stuff with it. So basically, if we run this, what we're going to see is when it sees my face, can you see that? It's so hard. Do my cameras. Anyways, so my face is here, and then it's showing the XY coordinates for my face there, right? So X is left and right, and Y is up and down. Now you notice the Y is inverted. For some reason in the computer world, the Y is inverted. So Y0 is at top and Y whatever is at bottom. But basically this will show you. You'll also see it keeps flipping up with other numbers every once in a while. What does it trigger as a face? Oh, there we go. It triggers that as a face. Come on. Can we just trigger that as a face? Can we do that? Does it think that's a face? Oh, can't see that. No. Oh, there we go. Okay. I'll stay right there. Oh, yeah, it does. See, look at that. We can actually fake a face. We can fake a face. That is hilarious. You may not realize this, but that's not a real human being. Oh, that didn't get triggered. Maybe it needs to be sadder. That triggering? Triggers off with that. Anyways, so basically with this, not only will it show the one display, but you'll notice when it triggers other places, it'll show multiple. So basically it just goes down. Let me show you this. Again, we go over here, make sure you do close it from within Python itself. So if we take a look at this script that we did before, everything down here is completely as it was. The difference is going to be in the detect and the display. When you're going through, I'm now trying to note wherever I make changes in this type of code with using the hash and the SD, just try to show you where that is at. So basically what we do is we start here, and the first thing that we need to do is we need to deal with the Y coordinates for the text as it's coming down the screen, right? So basically if you have 10 faces and OpenCV detects all 10 faces, and it tries to print the XY coordinates for all 10 faces at the exact same XY coordinates, you're just going to get a blurry yellow mess. So basically what we're going to do is with this Y coordinate, what we're going to do is we're going to do plus equal by 50 for every iteration of faces. So basically the first face, the XY coordinate will be here. The second face, the XY coordinate will be here. Third face here. Fourth face here. Fifth face here. Sixth face here. Blah. You get the point. So anyways, for X, Y, W, 8 in faces, Y coordinate is going to be plus equal 50. And again, for whatever reason, in the computer image world, 0 for Y is at the top, and whatever for Y is at the bottom. So when we say 50, so add 50 comes down, add 50 comes down, add 50 comes down, add 50 comes down. The center for each face, again, is that X plus width divided by 2, and Y height divided by 2. And then basically what we're going to do is we're going to print, so we're going to do cv.putText. So this is how you put text onto the screen. We're going to say where we're going to do it. So in the frame, all right, so the frame that we've created, then we simply use an F string here. So X, so center 0. All right, so we create center. The X is going to be at index 0, Y is going to be at index 1. So we're going to say X value for center 0, Y value for center 1. 50 is the X coordinate. So this is where you're going to be putting side to side. So 50 in from the left-hand side. So there's always going to be 50. So 50 in, 50 in, 50 in, 50 in. And then the Y coordinate, 50, 100, 150, 200. The text we're going to use is font Hershey Simplex. I don't know, that's kind of the default. Use whatever font you want to use. When I say this is the size of the text. This is the BRG, I think it's BRG color. So this is the color for the text, and this is kind of like the boldness for the text. And so that's where it'll print it out. And so that is essentially all you need to do to print something out on the screen. So again, like the X, Y, or the height, width, or whatever else. The important thing here isn't necessarily that you're printing it out on the screen, is that you're actually seeing that you can access these numbers, and again, into the future, be able to trigger events based off of that type of thing. So that's pretty useful there. So from there, we can go to the trigger event. Let's see here. Or no, first we do track largest object. Let's do best. Okay, so now one of the issues that you're going to run into. One of the issues that you're going to run into, especially if you have a face tracking device. So again, like with that robot, right? That robot is tracking faces, and then based off of where the face is, it's moving forward, it's going back, it's going left, it's going right. Here's an interesting question. If you're doing the whole XY thing, what happens if it detects 10 faces? What happens if it detects your face now, but then for some reason, it detects this over here as a face in a second, and then something over there as a face after that, and then everything kind of goes to hell, right? Because again, if you're trying to make something move, again, a servo motor or whatever else, that's being based off of the X and Y coordinates. One of the things you're going to want to try to do is get what is the best face or what is the best object out of this particular image and to track on that. And so that's basically what we're going to be doing here. Again, the exact same stuff that we had before. No changes down here, there. What we're going to be doing here, though, is again, we're going to be detecting for faces. So this is going to give us a list of the faces that have been detected. And then what we're going to do here is we're going to do an if statement. So what length LEN does is it tells you what the length of a list or dictionary or set is. So basically how many indexes are in this. So we're going to say if there are more than one face, we're going to do this thing called a lambda function. So lambda function is something we're going to have in an entirely different class. Basically, lambda functions are considered, I think they're called anonymous functions. And basically, it's where you want to do a little something with some data, but you don't want to go and create a full-fledged function in order to do it. You just want to make something nice and tight and easy. And so basically, what we're going to be doing with this nice little lambda function here is we're going to add face 2 plus face 3. So basically we're going to be adding, whatever it is, width. I want width and height. And so what that's going to do is it's going to tell me what the largest object is. So what is the largest face? If I'm tracking, I just want to track the largest face, whatever the biggest face is. There might still be some issues with that you might code into in the future. But anyway, so basically what we're going to do is we're going to create this index value. And with that, with a lambda function, we're going to say face 2 plus face 3. That's going to give us a total size. And basically here, what we're going to say is we want the max value. So from the faces list, we want to create basically a variable called face, which is face 2, which is whatever, width, plus face 3, which is height. And then out of this list, I want the greatest value of that. And then we're going to come back, and that is going to be assigned to the largest face. So we're dealing with the biggest face. X, Y, W, H equals largest face. So the face value, so basically this is a new set. I'm creating these values from that set that's come back. And then basically here, all this is doing is printing out like we did before so that we only find one face. We don't get this thing acting at least too sporadic. So we do this. So we should only see how before we got multiple faces at one time. So this, see it'll detect my sweat spots, but you'll notice it'll only detect one of them at a time. So basically it'll determine the biggest face in the screen, and that's what we're going to be working with, and it will ignore all of the other ones. So that's what's going on there. Then we get to triggering. So basically what this is, again, since we now have these variable values for x, y, height and width, that kind of thing, now we can start actually trying to do something with it. So in this particular class, we don't have Arduinos, we don't have IoT devices, we just have the screen itself. So basically what we're going to do is we're going to give the user commands. So think about this, if you've gone through TSA recently, so I've had to do a lot of flying recently, and one of TSA's things is they have this new biometric system where they swear they delete your images afterwards. Anyways, part of the biometric system is you hand them the ID card, they scan the ID card, and then they have a camera, and then when you're looking at the camera, it'll tell you to move left or right or up or down or forward, and then when you get to the right position, it takes the picture and does its biometric detection. So basically, more or less, that's kind of what we're doing with this particular script here. And so when we run this, well, yeah. So again, it's a little weird. I designed this on this computer and run it on this computer. This computer's resolution is different than this computer. Anyways, so what we have here is we have, see, this is the actual center of my face. So see where that, see where that plus is? Anyways, see where that plus is? That plus is the actual center of my face that it's reading off of. right? So it gives me the x coordinate of the center of my face, and it gives the y coordinate of the center of my face. And then basically what it's doing is based off of those numbers, it's now giving me instructions. So I'm in the middle, this way, more or less. So now it's telling me to go down. So if I go down, at some point, there we go. So now I'm down, a little far down. Anyways, and so it's fine, right? If I go down more, it should tell me to go up at some point. Again, different resolution. Anyways, so it won't tell me to go up because resolution's wrong. Anyways, so if I'm here, so I'm in the middle, if I go here, right, it's telling me to do right and down. If I go, oh, come on, you stupid thing. Wow, is the resolution that much different on the screen? Down, down, down. Huh. Anyways. Let's see if I'm farther back. If I'm farther back, will it work how it's supposed to work? Oh, that's interesting. Yeah, okay. Resolutions of screens. So the camera, so the numbers that I'm basing this off of are from the camera. That was bad. Anyways, the camera from my daily driver. And so again, I think this camera, I do believe, is a 720p camera. This camera is actually a 1080p camera. So the numbers that I put in there are going to be different, right? So if I go for the x coordinate, all right, so the y coordinate is, yeah, probably 720. Okay, so yeah, that's the issue that's going on. Anyways, but you kind of get the point. And this is basically how you have that robot operate, right? If the face is here, all right, the robot moves. The face is here, the robot moves, so on and so forth. Anyways, take a look at this. Basically pretty simple. Again, we want to track basically just off of the largest face. Again, if we're going to be giving directions, we don't want to give directions to 1,000 faces at the same time. So we're just going to be grabbing that largest face like we did before with the lambda function. Basically, we're going to come down here. We're initially going to say command underscore y equals nothing and command underscore x equals nothing, so that we declare and we set the variables as nothing to begin with. So if center 0, so center 0 is the x. X is left or right. And this is where you see those numbers. So if center 0 is greater than 1220, so this was on a 1080, again, 1080p camera, so it's different. If it's greater than 1220, command is going to equal left. If center 0 is less than 700, command is going to equal right. All right, so basically it's going to say, if it's over 1200, it's going to tell you to go left. 700 is going to tell you to go right. Else, if it's something else, it's just going to give you a blank, so if it's in between those. If center 1, so that's the y coordinates, if it's greater than 680, so remember those y coordinates, it goes from 0 down, so basically 680 is down here, 680 is not up here, 680 is down there. So if it's greater than 680, then it's going to tell you to go up, and if it's less than 400, right, you're up here, it's going to tell you to go down. And then basically all it's going to do is basically on the frame, it's going to tell you what your x coordinates are and your y coordinates are. I put the size as 5, so they're bigger here. Then we're going to put on the screen text. So at 50 in, so at 50 on the x coordinates, and then 270 down. So based off of the size, I figured 270 was good. So it'll be because we have this printing out first. So this is going to print out first. And then we have to move this far enough down so it's not writing over this. So that's a 270. And so we're printing this out, again, at size 5, so on and so forth. X, so the left or right, that'll be at 420, at 50. And that's what gets printed out on the screen. And the rest of it is basically what we've had before. And any questions so far? I think that's the video. So that's basically the video and using the webcam. Basically, this can be used with any camera very easily with any camera that's essentially detected as a webcam. So again, like I'm talking into these cameras, I use something called a Magewell device. The Magewell device basically turns an HDMI camera into just a normal webcam as far as my computer is concerned. So if I know what the index is, 0, 1, or whatever else, I can simply be pulling in the video feeds from that device versus the actual camera that's on my system. Anyways, any questions? No? Y'all awake? Y'all awake? Okay, let's see here. Nope, got a question from Jock. What's up, Jock?
You mentioned before a Raspberry Pi.
Yep.
You'll be able to put this script into a Raspberry Pi camera and do the same thing?
Yeah, more or less. Because if you looked at my old video, I was doing some projects about 2 years ago, and yeah, I was using it to try for my my little Lewis Rossman killer. So I had like a little Lego robot, and it could literally track this logo and would move based off of that, and that was all in the Raspberry Pi. I don't recall any special configurations. I think the only configuration you had to muck around with again might be that video ID, but everything else should work for you. Nope, did you mute yourself again? Oh, got a thumb up. Okay, cool. Yeah, yeah, it all works. It'll work on stuff. Again, it's just the speed. One of the things you have to think about with all this, again, that's where we talk about the stack, especially with hardware, is remember, with all of this, this is looping, right? So basically, if you come down here, if you take a look at it, we've got good old-fashioned while true loop. And what a while true loop is it goes just as fast as that hardware is able to run, right? So as fast as it is able to trigger that function, it'll trigger that function. But basically what has to happen is it has to take the picture or get the video feed that comes in. It has to process that using CPU, RAM, or whatever else. It has to come out with the results. With those results that we have, it then has to fire off whatever events are going to happen. And so basically the issue that you just simply run into is if you're using a 12-year-old computer to run this, OpenCV will run on a 12-year-old computer, and you'll know it's a 12-year-old computer. Right, that's kind of where it runs to. So yeah, it'll run on it should even run on a Pi 0. Like it'll run on a Pi 0. Might be a little bit slow, but again, it depends on what the solution is that you're looking for. Okay, need to figure out where my slides are. Let's see here. Then we get the static images. So basically, static images are just pictures. And so this can be very useful for any number of things. Basically, again, if you're going through and you need to detect certain objects, again, imagine you're at the marketing department for your company. And so again, you want to pull out every image that you folks have that has somebody's face in it, or has a car in it, or has whatever the hell you want to trigger off of. Basically, that's what you can do with static images. So we take a look at the static image, picture.py. So it's this one. Static images, it's a hell of a lot simpler. It's a hell of a lot simpler because it fires once and it's done, right? So if I run this, you ever had one of those days? Maybe unicorn's not there. Is unicorn not there? 1 second. Failed. 1 second. Oh, maybe I don't have this images. Okay. If you forget to copy the images to the folder, that is not OpenCV's fault. There we go. So basically, what we have here is we have a static image. So we have a picture of me with a peanut last Halloween, our last Halloween together, and basically it's detecting faces. So it found the face here and put a square around my face, and again, as I say, be careful. As far as the computer is concerned, that is statistically the same as a face, so it thinks that peanut has a human face there. So it basically just puts the squares around it. If we stop this, so we can do another image just to show you. So I have faces, and if I run faces, basically this is somebody that came here to Asheville to meet me, to whatever, have a consulting appointment, and so it sees my face and it sees his face. If we then go and we do a party, just to show you, oops, we do a party picture, we run that, and as we can see, we have many more faces, right? So basically you can have it, it can scan through, it can find faces or whatever else you're looking for, and then it'll show you that on the screen. If you take a look at this, again, this is pretty darn simple. So these images here, so you'll notice these have to be in my root directory, because basically that's just where I'm calling them from. So my Eli directory. So import CV2 as CV. Picture is going to equal whatever the name and the path to the picture is from your root directory. Image equals cv.imread, what that picture is. We're then going to convert it to that grayscale, as it seems to always do. The filter that we're going to be using is that Haar cascade filter. Again, so Haar cascade frontal face alt.xml. Result equals filter.detect multiscale, so the gray image that was created. Minimum neighbors equals 5, minimum size equals 20 by 20. So what the neighbors is with these filters, basically they do statistical analysis off of rectangles, really small rectangles, right? Anyways, and basically what it says here is the minimum number of triggered rectangles around the thing, right? So basically, when it happens, right? So it sees, so you have your big picture here, and then it sees one little triangle here. And that triangle statistically looks like a face. Or that rectangle statistically looks like a face. But that's a really small rectangle. And so again, is that really a face? Is that some jackass just making a smiley face on a board? Is it a shadow? Whatever else. So the minimum 5 neighbors, basically what it says is I want to see that 5 other blocks beside that particular thing that triggered it also are the same and basically trigger properly for having a face there, or for having the object detected there. So basically, the fewer number of neighbors that you have, the more objects that you're going to detect. Whether that is good or not depends on basically images that you're processing through. So again, that's where, like, how do you want to fail? Right? So if you're looking for faces or something, do you want to fail by having images that may not have a face in it, and you'll deal with that later? Or do you want to fail with images that may have a face, but they get dumped because the face isn't detected because the math doesn't look right? What is the answer there? Who the hell knows? Then you have a minimum size. So what the minimum size is this is by pixel. You can have a max size and a minimum size. And basically you say in the image itself, how big does that object have to be? So it has to be at least 20 pixels by 20 pixels. So again, think about that if you're with that marketing department and you're like, you know, what we're really looking for is we don't want faces. We don't just want faces, you know, that might be small. Right, so we run this. It's like, oh, you know, I mean, these are faces, but I don't know. Can you really see those faces? I want images that just are, you know, have the object at least 100 or at least 200 pixels by 200 pixels, you know, something that looks more like a portrait. And that's where you do that minimum in there. Or you can do a maximum, maybe if you want small. So result equals basically the multi-scale, the image gray, the neighbor, 2020. We come down here, so the result is going to come back as a list, and basically what we're doing here is we print out onto our screen, just so we can do troubleshooting purposes. All right, so this is showing me here the image that we're looking at, the x coordinate and the y coordinate. So I'm doing that for troubleshooting purposes. And then what we're doing here is, again, this is a for loop. So for each result, then we're creating a rectangle around the face or the object, right? Here's where the start of the x, here's the start of the y. X plus width equals how wide it is, y plus height equals how high it is. This is the color, and this is the border width. We then have to do cv.imshow. Basically, this is the title, whatever you want to put the title at the top, and then this is the image, right? That's what we're actually going to be displaying, and then you wait until somebody presses a key. So that's basically all you do for a simple picture. Past that, we can go. We start using things like OpenCV with HTML and CSS. Again, we start talking about that tech stack, everything that comes together. And so basically with this example, what we're going to do is we're going to scan through a folder. We're going to create a gallery. Anything that has the object in it will have a green border around it. Anything that doesn't have the object in it, it will have a red border around it. So if we go to the picture tag, basically take a look at this. Again, still pretty simple code. I click on this, so it runs, it's finished. And we come here to gallery.html, and so there we go, right? So basically we can take a look and you can start to see what OpenCV triggers off of and what it doesn't trigger off of, right? So this is me, again, I don't know, a woman from Missouri that used to watch my videos, so it detects faces there. It detects faces there, detects faces there, doesn't there, interestingly enough, doesn't there, obviously, does here, curiously enough, doesn't there, doesn't there, does here, nope, yes, right? And so this can be a very good tool for you, especially when you're talking to decision makers, to start to try to explain, the pros and cons of using this particular technology. Again, if you go to your CEO, if you go to your executive, and you're like, yeah, it's going to work pretty well, but there is going to be a failure rate involved, they're going to blow you off. Oh yeah, it's going to be fine. Eli, it's AI. It'll be perfect. I don't think it's going to be perfect. So one of the things you can do is you can create some kind of system like this to actually very quickly be able to show your executives, how well or how not well it works. Again, for a marketing department, this might be great. It's like, look, Eli, found exactly the faces that we want. So, maybe some people are left out, but it doesn't really matter. That's not what the marketing department cares about. A different department might be like, well, we want to make sure everybody, is involved, so they may care. Basically, we take a look at this. Again, this is just simply combining what we've done before with some HTML and CSS. So CV2 has CV, import OS. So we're going to need the OS module. So we're going to create a list of the pictures. So I have a folder within my root directory called pics, and in that we have these images. So picture list equals os.list directory, so all the images in there. And then we're going to print that out on the screen just so I make sure everything's working properly. Filter equals cascade filter. This is the cascade filter we're going for. We're then going to create the gallery. So file equals open, gallery.html, W for overwrite. And then basically what we're going to do here is for picture in the picture lists, each image, color equals nothing to begin with. So try. So again, whenever we're interacting with the operating system, whenever we're trying to take an action, you want to do a try except statement. So if the action fails, Python knows what the hell to do. So it's going to try to read the image. So image equals cv.imread, basically just use an f string, pics folder, and the picture that's coming in. We're going to turn it to grayscale. We're going to detect. And basically if the results here are greater than 0. So basically to detect something, color equals green, else color equals red. And we're simply doing file.write, image style equals height of 200 pixels, width of auto, border is 20 pixels, whatever the color is, solid. And then I put embed the picture itself, picture, except, so if there's a problem, it just passes. We don't do anything at all. and then we file close. And basically with that, that is where we get this. And again, if you dump more images into that folder, it will then just be able to scan through. And again, on a decently fast computer, you can see how fast that runs. So these are all full-size images, and it's able to do this pretty quickly. Any questions up to that? What if you increase the photo size? Will that make a difference? Yeah, well, So if you, let's say this is a 10 megapixel camera. So if you increase the size, as in bringing more information in or increasing the quality, that will make a difference. So it's triggering off what it sees. So you need to increase the quality. So the resolution or the quality, that will make things better. If you just do size, so again, especially with like pictures, again, you have like raw files and that type of stuff. You have to turn this into like a JPEG in order for it to work for OpenCV. You might run into a weird issue where you have a better picture that doesn't necessarily process better. So if you're giving it more detail that it can actually trigger off of, it'll do better. That makes sense. Okay, let's see here. So we have that. Then we have the bounding box. So basically with the bounding box, what this is going to be, make sure, bounding box at HTML, is again, this is using HTML and CSS. And we don't necessarily want to know just that there is a face and an image. We actually want to be able to see that face, but we also want to see it in a data format that we can do something with. So, when I've been showing you the bounding boxes in the past, that has been through OpenCV's little image thing, so you can see it. That's not necessarily useful for most people. It would be a lot nicer to be able to actually show the bounding boxes and things using HTML and CSS. So basically when I run this, it will detect the image, and then with HTML, so I'm using Safari for this. So with HTML, what this is doing is this is embedding the image for us, and then it's putting the bounding boxes over this image. So this is using HTML and CSS. What this is this is actually divs. So you know the div tag. Maybe you don't know the div tag. Anyway, the div tag, whenever you're building a web page, you're basically going to be separating things out with div tags. One of the things is the display, how you display the div tags. So what happens here is we create the bigger div, and we're going to give it a relative display, and for the internal, we're going to give them absolute. And anyways, that's what gives us these boxes. We go over, I can kind of explain it. So if we take a look at this, again, so we got the unicorn faces, all that kind of thing. One of the things that you need to do here is you need to install the pillow module. Again, anything you're going to do in Python, you do need a module for. Basically what pillow allows you to do is it allows Python to interact with image files. So one of the things that we need in order to be able to do these bounding boxes is we're going to need the size of the image itself. Again, that's where a lot of people ask, like, do you need to know math in order to do technology? And it's like, well, you don't need to know calculus, but you do need to know some pain in the ass basic math, right? So again, so if you're going to put a bounding box here, you have to figure out the math of understanding where to put that X, Y, and then how to make that box actually show up. And that's what we're going to use pillow for. So we come here again, pictures, you got unicorn faces, party, whatever. Image, we're going to read the picture, so this is for OpenCV. We're going to turn it to grayscale. We're going to throw it through the cascade filter. We're going to look for a minimum of 5 neighbors. We're going to look for a minimum size of 20 by 20. Then we have this information here for pillow. So IMG for pillow, we're going to open the picture. So with pillow, I want to open the picture, and then what I'm going to do is from this, I want to get the width value, and from this, I want to get the height value. So IMG width and IMG height, that is the width and height for the actual picture file itself. Then basically we're going to come here, we're going to open a document, basically bounding-box.html. We're going to make it overwrite. Then we're going to write, so we're only doing this once here. So we're going to create div style position relative. So for the, it sounds weird, but the underlying div, you actually make that position relative. And the overlay divs, you make them absolute. Sounds backwards, but that's how it is. Anyways, we're gonna make a border of 5 pixels, solid and black. The height of this div will be the image's height, and the width of this div will be the image's width. So basically we're gonna create a div the exact same size as the image itself, and then we're going to embed the image within that div. Then, let's see here, for X, Y, W, H, and result. So we get that list back, so we want to do the bounding boxes. So we're going to print out, just on our command line, picture the X, Y, the width, and the height, just so we know what it is. And then we're going to write, so div style, so for each result, each bounding box, we're going to write in the bounding box. So the div style, so this is going to be each bounding box, position absolute. So it has to be absolute position for the bounding box. Border 3 pixels, solid red. The height for it will be H, that's coming in. The width for it will be the width for it. The Y pixel and the left pixel. So basically with this, you have the full image size, and so it's going to make the height, the width, the X and the Y based off of the actual image size. Why this becomes some tedious math. So, alright, so if this is your image size, and if these are your two faces, right, you're going to have your X be here, and your Y be here, then you're going to have the width, and you're going to have the height, right? And you're going to have these numbers. That's pretty simple, right? You're going to run this through OpenCV. It's going to give you your X, it's going to give you your Y, it's going to give you your height, it's going to give you your width. Done. Welcome to the most obnoxious math that you're going to have to deal with. But many times, you're not going to want the picture to be this big, right? So this picture that you're seeing right now is the picture, the actual size that is displayed. What if you want to do a gallery of pictures? Kind of like what I showed you before. See, these pictures I shrunk down, but what if I actually wanted bounding boxes in these shrunk down pictures? That's where you got to figure out the math. So if basically, let's say it's 1,000 pixels for the X, and let's say it's 2,000 pixels for the Y. So let's say you want to make it half the size, make it easy. So it's 500 pixels by 1,000 pixels, right? So basically you're just trying to shrink it down. Well, here's the thing. If you use the X, Y, height, width coordinates, that's basically going to put your bounding boxes like somewhere else, right? Because if you have a 500 pixel by 1,000 pixel and you're using the exact same X, Y, height, width, it's going to put it somewhere else. So that's where you've got to do the math of, if this is 500 pixels and this is 1,000 pixels, and you got that face going on and that face going on. So basically what you do is you divide this one, you divide 500 by 1,000, right? And that's going to equal, let's say, 0.5, so half. So then what you do is you do X now equals X times 0.5. Y equals Y times 0.5. Height equals height times 0.5. Width equals width times 0.5. So now, instead of the XY being over here, the XY will be over here, instead of the width being all the way over here, right? And that's where you've got to do The tedious math. The tedious math. Don't worry, you don't have to know calculus. God help you, you do have to figure this crap out. So anyways, we're not doing that particular thing today. But again, that's the kind of thing to be thinking about, again, when you're displaying these images and thinking about things like how is that math going to work out for things like the bounding boxes. And then here's just a gallery. Is there any questions? All right, we're getting close to the end. So basically, the bounding box gallery, what we're going to do is we're going to run this. It's going to go through. It's going to process. Again, I print this stuff out just so I have a troubleshooting routine here if there are any issues. And then I'm going to go to gallery.html. Gallery.html just got created. And so there we go. So now, again, this is the images that we saw before, but these are the full size. I'm not doing this math because I just didn't have the brain power today. So these are full size images. And so this shows me, okay, my face is here, her face is here, and there's a background face here. Again, what it starts to show you, though, is how weird this is. So she triggers as a face, he doesn't, she doesn't, which is kind of curious. Again, if I'm here, I trigger as a face. A book doesn't trigger. None of these people trigger. One person triggers here. He doesn't trigger. He doesn't look too happy. He didn't get triggered. Triggers, I don't trigger. None of those people trigger. I trigger once there. All those people trigger there. None for there. And of course, the famous picture now. Both of us trigger there. Again, what becomes interesting with this kind of thing is you can start playing with stuff. Again, where is that? Again, like the minimum neighbors. Let's say I put the minimum neighbor down to 5, or down to 1, right? So if I run this, it should find more people. Or it will find more things to trigger off of, right? So that's the same. Okay, so if I do one neighbor, so he's now detected, she's now detected, and that blob is now detected, right? So that's actually better. On the other hand, if you look at this, my face is detected, and also for some reason the microphone is detected. If we scroll down, we can see here that my wood table is detected. Scroll down more. Again, now that guy is detected, and that person's detected. My arm. I have a hidden face in my arm, right? None of those people are still detected. And yeah, hair is detected. Again, it doesn't see, just does statistical analysis. And there you go. So that's where, like, when we're talking about with how many neighbors, again, as you saw, that improved the number of detections, but we also got a lot of false positives there. In this code, again, this is all up on GitHub. I did just leave these other Haar cascades in there for you to play with. So basically all you have to do is you just have to reference the particular cascade that you care about, and it'll try to work. So if we comment that out, and I don't know, we do upper body. Let's say upper body with one neighbor. Let's see how this does. Okay, now there we go. Found a lot of upper bodies. So I refresh, and so that's an upper body, that's an upper body. Okay, that's not exactly, my knees are upper bodies. That did not work out well. Let's do 5 neighbors. So you do 5 neighbors, and you run it. A lot less. Refresh again. So he comes in as an upper body, I come in as an upper body, and her ear comes in as an upper body. That comes in as an upper body. Anyways, so you can play around with these filters and see what the differences are. Let's see, if we take a look at this. Again, basically pretty simple code here. So CV2 as CV, we're still going to need pillow. We're going to import image and import OS. And we're going to create that list like we did before. We're going to print out the picture list so I know what the hell we're dealing with. We're then going to create a gallery.html document so that we can write all this into it. So for picture in the picture list, we're going to try to read the image. We're going to turn it into a grayscale, and then we're going to say what cascade filter that we want to use. We're going to detect, again, play around with those neighbors. You can play around with minimum, maximum size. We're going to get the height and the width using pillow as we did before. And then we're doing the same thing, you know, div, position relative, border 5 pixels, black, height is the image height, width is the image width. So it depends, so the image itself, right? So the div size, you'll notice these divs are different sizes. And so that's based off of the values coming in from pillow. Then we're going to embed the picture itself. And then again, this is where we come through, and then based off of that image size, we're then going to do the bounding boxes for every single result. So basically every face that we've seen. If there's a failure, we're going to pass. We just pass, and then we do need to make sure that we close the file down here to make sure that the file gets closed and it's not open. And that is what gets us this. And I think, no, got some more. Okay, yeah, bounding boxes. So training OpenCV. Again, so you can train OpenCV. We're not doing that today because it gets to be a bit quirky. We'll have a more advanced class where we'll get into it. It's not too hard though. One of the things you need to be thinking about when you train OpenCV, if you go out and you find how to do it, basically you need a Windows computer. You need to go through some obnoxious process in order to do it, but it's pretty easy. Like once you have the process down, it's relatively easy. Just got to get the process down. But one of the things to realize though, again, is that wait, tell me if you've heard this before. The computer doesn't see. The computer doesn't see. Right? And so one of the things you'll notice with the Haar cascades is they have Haar cascades for frontal face and they have Haar cascades for profile face. And the reason is because statistically, this looks different than this. Right? It's not learning what a face looks like. It is simply doing the statistics on this and it's doing the statistics on this. So if you go and you decide to train, right? What if you decide to create a competitor Lewis Rossmann destruction bot? You realize I have done such a great pitch on the value for humanity for the complete destruction of Lewis Rossmann. What if you decide to go out and build your own Lewis Rossmann destruction bot? One of the things to think about is to consider what kind of angle you really want to go for training your filter, right? So one of the things to really think about is the less variance your filter has to learn, the better it's going to work. So what I would argue is, like, again, if you're using this, you're going to trigger off of Lewis's logo. You might do a little bit bend. I don't know, maybe like a 20 degree. That probably makes sense. 20 degree left, 20 degree right. So what happens is you just take a lot of pictures. Like the training process is you take a lot of pictures of this. Right? So you take 20, at least 20. So I think it takes at least 20 in order to actually be able to train. You should probably take about 200. Anyways, and basically you take the pictures in slightly different light at slightly different angles, and then you go through the training process. You have the positives, you have the negatives, doesn't have anything in there. You go through, you just put a box around the object that you're looking for, you hit the train button essentially, and it sits there and it takes about 10 minutes to train. Anyways, so one of the things you may want to think about with the training is that you train different cascade filters essentially for different angles. So you might want to do one cascade filter that basically does this, and then you might want to do one cascade filter that does it at that kind of angle, right? And the reason is the less variance in the images that you provide, the better the cascade filter itself is going to work. And so it might be better for you to create multiple cascade filters and run it through multiple cascade filters than try to have one cascade filter do everything. Because this looks like this. But this, again, from a computer's point of view, might look like a lot of other things. And this might look like a lot of other things. Kind of get what I'm saying with the whole training thing? So anyways, think about that if you actually go out there and do training. We will do training in the future because Lewis Rossmann has got to go down. And we need an army. We need an army of bots to take him down. And then the final thing, again, we don't actually have labs normally when we do these classes. We have at least 3 labs. Again, here's all the code. You go play with it. Should work fine for you. We're not doing that today. So final thoughts is, again, do remember, I've said it before, computers do not see. It's computer vision. Computer vision It's just an easy way of explaining what is going on. It's not really what's going on. They process as images and are based on numbers. What the hell did I say? They process images and based on numbers they assign values. Right. So it looks at an image. It creates numbers. It then takes those numbers, looks to see if those numbers correspond to something. If it does, it comes back with whatever the hell you named it. Again, is that seeing whatever? You are the human, act like one. Again, a lot of this stuff, a lot of this AI stuff, is a lot of people want to hand their brain over to their computer. Like, that's the weirdest thing in the world that I found with the modern world. So many people just want to hand it all over to the AI. And you're like, no, don't do that, right? When you're building these systems, you've got to be the human to build these systems and realize where there may be issues and that type of thing. And it's also, again, thinking about how you design the system and how you interact with the decision makers, again, the people that are actually able to write the checks. Right? One of the things you need to do is you need to test these systems to see how they're working, and then be able to show, again, the people who signed the checks, basically some types of results for why you are concerned. Again, the more documentation you have, the more likely you are to get a budget. And so again, if you're doing something and then you can show the people writing the checks, right, look, this is the issue that is going on. You know, these are the actionable plans I think we should take. Right? Again, imagine, like with this, imagine if the door unlocks or something happens whenever the computer sees a face. Right? And then imagine it doesn't see 13% of the faces in the company for whatever reason. Right? Again, it just is as it is. So one of the things you can think about is, okay, how can you go to the decision makers to explain how you think you're going to solve the problem? Look, so we're using the cascade filters that we were provided. These cascade filters, X number of time, and frankly, they seem to fail a certain type of person. How can we try to solve these problems? So one of the things you might do is you might say, look, I want to go, and again, since we're using pre-trained filters, maybe the issue is we need to manually train a filter. So I want to go from surveillance cameras or whatever else that we're using. I want to get 3,000 pictures of all of our employees and different lighting conditions or whatever else, and I want to manually train a cascade filter off of our images that we already have. Again, how long is it going to take? Talk about the budget to them. It's like, so if we do this type of thing, it is going to take, approximately 40 man hours. So we're going to have to collect all of the images. We're going to have to process all the images. We're going to have to make sure it all works, that type of thing. So this is going to cost, 1 man week of work for somebody to sit down and actually plug through this. And then you can say, and I think this might solve the problem. But again, one of the issues that you might be dealing with is once you convert to grayscale, right? Maybe detail gets faded out. So one of the things you can think about is like, if we were using different visual cameras, maybe that would solve the grayscale problem. What if everybody was the same color as far as the computer is concerned? Think about something like an infrared camera. It's like, okay, well, we already have these cameras and already these systems. They're set up. They're set up for visual light. Visual light is running us into these problems. What if these cameras were set up just for IR? So it blasts out IR light. You get the reflection. Using infrared, you're just getting infrared back, and so then you can train just off of infrared images, and then you can trigger just off of infrared images. And so then you go to the boss, and you're like, okay, so if this manual thing doesn't work, maybe the infrared thing will work. Now the infrared thing, again, if you look at it, each camera is going to be an additional X number of dollars. It's going to take an additional X number of man hours to install these damn things. It's going to take an additional number of man hours in order to get all of the images, because we definitely don't have infrared images of people laying around. So we actually have to get 2,000 of those damn things. That has to get processed. That has to get tested, the whole 9 yards. And so you can lay that out to your executive. Or you can just say, is this really worth the time? And then they can make the decision. Again, as a technology professional, your job is to either solve the problem or give the decision maker an actionable plan for how to solve the problem. I've gone as far as I can with the resources that I have. This is what the next steps are. You are the decision maker. Sir, yes, sir. We'll do whatever the hell you said. I've done my job. Right? And so again, that's the kind of thing you need to be thinking about with computer vision and a lot of this kind of like IoT, AI-ish type stuff out there is, again, what if it doesn't do what you think it's going to do? So anyways, there we go. Is this how Apple trained its face scan app to open their iPhone? Relatively. Yeah, so one of the things you'll notice with Apple is when you use Face ID, they don't use the visual camera, right? They've got this whole thing where they use lasers or God knows what, and it detects the points. And again, by doing that, skin color no longer matters, right? Again, and that's an important thing to be thinking about this. Like that's one of the things like with Silicon Dojo. Again, I talk about that. Good systems default to good outcomes. Bad systems default to bad outcomes. If you have, something in the system that can allow for some kind of prejudice, that's going to happen, right? So again, if you're dealing with cameras that are dealing with visual light, I mean, the reality is whatever camera you use, whatever system you use is going to be working differently with whatever the hell it's seeing. And so one of the things to consider is, again, is getting at, it's like if we know that visual light spectrum inherently runs us into some problematic issues, maybe visual light spectrum is not the way that our computers need to be seen. Yeah, and so that's why, with their Face ID, whatever the hell their system is, it doesn't use like the normal camera the way that we think about it, and that's why it's generally pretty accurate. Let's see here. If I change the image from JPEG to a PNG, WebP, GIF, or SVG, will it even work? That's a good thing to plug into OpenAI or ChatGPT and ask it. I'm not sure. It does PNG and it does JPEGs. I'm not sure what other image files it deals with. So again, it's just a specification thing. You learn to say, what does OpenCV interact with? And it will tell you, and that's what it does. So anyways. Any more questions? That's the end of the class. That's all I got for today. Wow. Only 2 hours. Only an hour and 50 minutes. Anybody have thoughts? Anybody have questions? Anybody awake? I really gotta get that virtual koosh ball going. I just gotta be able to throw a koosh ball through the internet. Dun dun dun. Okay, is that it? Nobody else? Nobody questions? No thoughts? Oh, yeah, thumb up. Okay, cool. No questions. So we're going to be doing another DIY class on Tuesday. So hopefully it won't be the goat screw of last week, or this week. It was this week. Anyways, I learned some lessons from doing that particular one. For the DIY classes, we're going to leave it to 5 labs, because I thought I needed more labs, but 7 is way too many. So we're going to leave it to most 5 labs. And the nice part too is with OpenAI, you don't have to parse this data as much. Parsing data is just, again, it's not hard. It's just, yeah. So anyways, so we're going to do the OpenAI DIY. So we're going to do like, basically giving OpenAI a caching system. So if you ask a question, imagine if you're creating a system for a company. If somebody asks a question that's already been answered, if you have a caching system, you can just pull from the local database instead of going all the way out to OpenAI. So we're going to do that. We're going to have the photo gallery thing. So when you ask for an image, it'll auto download the image plus save information into the SQL database. So you can do searches and things like that later. We're going to give it a memory so we can talk to it and it will remember what we've talked about. So those are going to be kind of the projects that we're going to be dealing with on Tuesday. And then I don't know, maybe next Friday we have to deal with parsing. Oh God. Maybe next Friday we got to do with regex. Regex. Regex is to the coders what subnet masking is to sysadmins. But you got to learn it sometime, I suppose. So anyways, that's all I've got to say. Okay, put up the formats. So that's all I got to say. If there are no other questions or comments, I'll see y'all later. And again, this video will be up on YouTube. You know, I don't know, by Monday. So anyways, with that, see y'all later.